So this is being recorded. Tomorrow when you come in, we will be doing an assignment, talking through. I'll finish up my lesson. Then you're going to probably practice some more on your own. While you're practicing on your own, I will be giving you out a textbook and a workbook for all my kids that are face-to-face. You can see they're there. You'll be getting that tomorrow. We'll talk through more of the how to use the workbook and the textbook and what I expect from you. But that will happen tomorrow. So today we're going to continue on the lesson 1.2 that I started on Friday. And let me actually, can I pause? All right, so here's kind of what we talked about, picking up 1.2. All right, so the thing you need to understand is if we have f of x, first off, what does that mean? If I say f of x, what does it mean to be a function?
Doesn't it mean y? Like, isn't y f of x?
F of x is the same thing as y, but it tells me more than just y. Okay, there's a couple things that we need to talk about why f of x is better. I need to review that in my other classes too, but there's a couple reasons why f of x is better. First off, it tells you when I say it's a function, it means every x goes to 1 y and only 1 y. So like if I said, is this a function? Well, what I personally do is I go like this. What does 1 go to? If I put a 1 in, right, this is my input, this is my output. So if I put a 1 in, what am I telling you you're going to get out? A 5, right? So this input has how many outputs? 1. 2 goes to what? 3 goes to what? And 4 goes to, so is this a function? Yes, it is. It's a function. Another ordered pair. These are charts, right? Is this a function?
No.
What does 1 go to? What does 2 go to? What does 3 go to? What does 4 go to? Does every input only go to 1 output? Does each one of those inputs only have 1 arrow coming off of the input? Yes, it does. This is a function. Does every x only go to 1 y? Yes. Now, do they all go to the same y? Yeah, is this y cheating on a lot of the different x's? Yep. But here's the thing. The x has to only have 1 girlfriend. But the girlfriend can have multiple boyfriends. The 2020 girls, we're making the switch finally. Play on, player. Your X can only have one output, but the output can be happening multiple times and it's still a function. Does that make sense? Yes or no? Here's an example of not a function then. Does everybody see my inputs and outputs? What does 1 go to? What does 1 go to? There's where the problem is. What did you say? 5 went to, or 1 went to 5 and 6. There's an input who's got 2 different outputs. That cannot happen in a function. Over here on the one that was confusing, what does 1 go to? Do you notice how you just said 5? You didn't say an and. That's why it's a function still. Each one of the inputs only went to 1. Now again, they went to the same output, but that's okay. We're not allowed to have an input that has 2 different arrows coming off of it.
So y can have the same number of x's?
Y can have a multiple amounts. Yep, Y can happen over and over again. Not for it to be a function. Now, if we just classify something as a, like, it's just a graph, that's when we would just use Y equals. So when something's not a function, we have to make it Y equals. Like a circle is not a function, okay? An equation for a circle looks like this, okay? If you notice on a graph, let me go back for a second. If something is going to be a function, you also had, if you had a graph of it, you had this thing called the vertical line test. And as long as it only touched the graph once, you should have been taught that in Algebra 1. As long as it only touches it one time, then it's a function. It was called the vertical line test. Does this pass the vertical line test? Yes. Each time, it only touches the graph once. Does this pass the vertical line test? Boom. Hits here once, same line hits here twice. No, that's not a function. So you would not be able to write this equation as f of x equals. You couldn't do that. Why? Because it doesn't pass that. What would you have to use instead? Y. Okay? Now, remember how we talked about the thing where every x has to only have one output, but y can be repeated? In real life, we want everyone to have one boyfriend, and we want every boyfriend to only have one girlfriend in this utopia of a world, and no one ever cheats on each other, and it's just love and peace, and there's no girls slashing each other's tires and boys doing things that, yeah, right? Like, that's called a one-to-one function. In a one-to-one function, every x has one output, and every output has one input. That is called a one-to-one function, what we want the world to look like. Michael Jackson should sing a song about that, or should have. Too soon? I don't think it's too soon. Rest in peace. Love, Mikey. Yes? Is this a function? Does this, each line, only hit it one time? Yes. Not only does each vertical, but each horizontal only hits it one time. What does that mean? Every input has an output, and every output only has one. So what does that make this function? I just said it. It's a one-to-one function. If it passes both the vertical and horizontal line test, it is called a one-to-one function. Yes, ma'am. Give me a minute. Is this a function? What do you do to tell whether it's a function or not? Does this line only hit it one time? Yes. Is there any spot that I could draw where a vertical line would hit that graph twice? No. So guess what? It's a function. Is it a one-to-one function? Why not? All it has to do is have one time that it fails. And right here, it hits how many times? 3 times. So this this y value, which we'll call, let's say that's a height of 1, up 1. Do you see how it has 1, 2, 3 different x? That girl's got 3 different boyfriends. I don't know how she's dealing with that, but hey, power to her. I can't even handle one girl. Mood swings and all that stuff. I don't know. It's just mess up constantly. You know what I'm saying? No? You will. Questions on this? Make sense for one-to-one? Makes sense for function. So that's the reason why I say it's a function, because when I tell you it's a function, I've told you every x has only one y that it goes to. So now everything that I do, I'm writing right now as a function. These are all things you should have seen in Algebra 1. What kind of shape is that top one going to be? F of x equals x. What kind of shape will that be every single time? Nope. It's going to be just a line. What is every time you see x squared going to be? This one's going to be a u, which we call a parabola. And every time it's an absolute value, what kind of shape did I say it's going to make? A V shape. Now, do you see how these have no plus, minus, multiplying, anything attached to it? It's just really generic. We call these the parent functions. These are the parent functions for what you've studied so far. They're the OGs. Nothing has happened to them. And what we're learning today is what happens when I add and subtract things in different spots. How does it move it? How does it shift it? What happens when I multiply it by a number? We're going to learn that before I even graph this thing, I'm going to have an idea of what it looks like because of these things I'm going to teach you today. So, if I said f of x equals the absolute value of x. Now, these rules work for every function we're going to come in contact with this year. That's why if you learn them now, it's going to make it a lot easier later on because it works every single time. So, what happens with this one? Let's just look at this graph. By the way, I told you this earlier. If someone ever asks you to graph something and you can't remember what it looks like, you can't remember my voice and how wonderful it sounds, you can always make a X and Y chart to get the graph. An X and Y chart is just you pick X's, you plug them in, and you see what comes out. So like if I was doing this, I would just pick easy numbers. What would be the first number I would choose? Even easier than 1. 0. If I put a 0 in here, what's the absolute value of 0? Now, Nick, what next number would I put in? What's the absolute value? 1. Next number, what's the absolute value of 2? Now I need to go the other side. So instead of continuing in the positive numbers, what number could I put in there? What's the absolute value of -1? What's the absolute value of -1? It is 1. Absolute value is the positive machine. Whatever you put, whenever you finish it and you go to do the absolute value, it makes the number positive. So like if I had, just for an example, just hold on one second. If I put a 1 in here, right? I put a 1 in, 1 times 2 is 2. 2 minus 10 is -8. What's the absolute value of -8? 8. That would be my final answer. So after you do all the math inside, it then kicks everything to positive. That's what absolute value means. So what's the absolute value of -2? So here's my OG. Zero, zero, 1, 1, 2, 2, -1, 1, -2, 2. And that's kind of what it's going to look like. That's the shape. Remember when we graph, we cannot possibly get every answer because how many answers are there to this equation? Infinite amount. But I'm just giving them an idea of where the answers are going to fall. Remember, a graph is a visual representation of all the answers. That is absolute value. And absolute value just says, I don't care whether it's positive or negative, how much is it worth? So like -8 is worth 8 in the negative side. I don't care which way it is. I just want to know what's the value. 8. What's the value of $10? 10. What's the value of -$10? 10. I just care how much it's worth, not whether it's positive or negative. Make sense? What if I asked you to graph this one? And these are the kinds of things I'm going to teach you. This is what the goal is of today. What the heck does that do? And I told you it's going to move it up 3, right? When it moves it up 3, what value is it only going to change? So like it's no, up and down is y, not x. So guess what I can do with all my x coordinates over there if I wanted to? Nope. Nope. Just nothing to the x values. The x values are going to stay the same. What's going to change? So instead of being 0, 0, it's now going to be 0 what? 3. Instead of being 1, 1, it's going to be 1, 4. Add 3. Instead of 2, 2, it's going to be 2, and so on. Does that make sense? And we talked about this on Friday. I'm just reviewing it. Whenever something moves up and down, we call that vertical, yes? So this is called a vertical shift. So if I ever ask you to describe this, you would say that's a vertical shift up 3. Or vertical shift positive 3. Tell the person that you're moving up 3. How are we doing? Absolute value. It's just an absolute value graph. It doesn't have like a certain name, like a parabola. Not all of them. In fact, parabola is really the only one that's weird that has that name. Yep. All right. So here's the new one. That's a review from Friday. This one. Now, how do you think that's going to move it? If the outside one moved it up and down, what do you think this one's going to do? It's going to move it left and right, but it moves it the opposite way you think. So I would think that this would move it left because it's a -2. So it's not going to move it to the left. It's actually going to move it to the right 2. The inside one always does the opposite way you think. Yep. So this one is actually going to move it to the right 2. And again, we'll show you. If you put the x and y, 0, 0, this is my original, 1, 1. We already did this. There's no reason to redo it every time. This is my parent function. I don't know why this thing's not writing. Here's my parent. Does everybody understand what I'm talking about? I'm not taking my time on the parent every single time. It's the same. This is the new one. If I put a 0 in, what kicks out? Nope. Careful. I'm not doing it the same way I did this one. I'm actually plugging in. If I put a 0 in, what's 0 minus 2? But what's the absolute value of negative 2? 2. What if I put a 1 in? One minus 2. And then absolute value negative 1. What if I put a 2 in? 2 minus 2 is 0. Absolute value is 0. What if I put a 3 in? 3 minus 2. Absolute value of 1 is? And then finally, if I put a 4 in, 4 minus 2 is 2. Absolute value of 2 is 2. Now look at this thing. 0, 2, 1, 1, 2, 0, 3, 1. Boom. Do you see how it moved to the right? 2. Exactly like we said it was going to do. Every point moved. 1, 2, 1, 2. This point that was right here. 1, 2. Point that was here. 1, 2. Do you follow me? Yes or no? Yes. Now, what would happen here? You should be able to tell me 3 things that you know about this. Let's go here. What is that going to tell me? So I know it's going to move up 4. I know that it's because it's x squared. I know my shape is going to be a shape of a U. And what else do I know? It's going to go left 3. All this before I even did anything. I told you before you graphed it, you should have an idea. That means that I know my original parent function looked like this. Do you follow me? Yes or no? How is this going to help me? I know I'm going to go left 3 and up 4. That means that when I draw my X and Y chart, where did I zoom in? What quadrant did I zoom in on? I zoomed in on 2. Why? Because this parabola is going to be moved left. Was it 2 or 3? Left 3 and so I knew this is where this is my original vertex. This is now that point being moved over 3 and up 4. That's why I zoomed in on that one, because the majority of my parabola is going to fall here. Do you follow me, yes or no? And do you remember how what would be this ordered pair, by the way? Negative 3, 4. So I'm telling you, if I plug in negative 3, I should kick out a 4. Well, let's try it. What's negative 3 plus 3? 0. What's 0 squared? And what's 0 plus 4? Did I put in a negative 3 and kick out a positive 4? Now, what would be my next x's? Because remember, I have to get this full shape. So what would be the x's that I would plug in to finalize the shape? Because I'm not finalizing it right now. That's not my goal. What? Why did you say negative 2 and negative 1? Because they are right next to my vertex. Who gets to pick these x's? So I'm going to pick x's that are close to my vertex. Notice we didn't do 1 and 2 this time, did we? Do we always have to plug 1 and 2 into the graph? We get to pick the x's. She said -2 and -1 because we want to pick it close to this vertex. What other numbers would I choose? Because that only gets me to the right side. That only gets me this side. -4 and -5, which would get me this side of the parabola. Is that making sense? Questions on that so far? All right, what would happen if I had this? What the heck does this do to it? So this right here is what we call a vertical stretch. Imagine I have a rubber band. And what if someone pulled from the top? I was holding the bottom. The rubber band kind of just was holding its normal shape just on its own. What if someone pulled the top of that rubber band and vertically stretched it? What would happen to the rubber band? It would get what? Really skinny? Does that make sense? So imagine that someone was pulling on this arrow, and they're pulling it up. What's going to happen to the parabola? It's going to do what? It's going to get skinny. We call that a vertical stretch. Anytime this number right here, again, notice where it's at. I'll write it like this for you. You see how it's like outside the parentheses? Remember what I said, everything outside the parentheses has to do with being vertical, right? If this was a +2 back here, this would be a vertical shift. Everything outside is vertical. So this is a vertical stretch. And that's going to make the graph skinnier. If it's a number less than 1 but bigger than 0, like this is called a vertical compression. What would happen if I took that rubber band and someone pushed down on the top of the rubber band? What would happen to the rubber band? If someone pushed down on the top of my fingertips, what would it do? It's not necessarily shrink, because it's still the same size. I'm not worried about that. Do you see how it gets wider? That's what happens when you compress. So imagine, this is the OG, this is the original. What if someone put their hand here and pushed down on those arrows? What would they do? They would start to get wider out. That's what we call a compression, because it's like someone pushing down from the top. That's what happens when you have a number less than 1 but bigger than 0 over here. Pay attention to this, please. It's going to be what we use throughout the year. We will constantly refer back to this. Anything between 0 and 1. Anything between, so it doesn't have to be, it could be a decimal fraction, right? Anything between, any number between 0 and 1 is going to be compression. All right, what if I have this? And we're going to hammer this home tomorrow, but we're going to start it out today. What if I had this? Again, notice that's outside the parentheses. That would be like this. It does have to do with being vertical, but it's actually a vertical flip. So you see right here, it flips it vertically, meaning it flips it over this axis right here. And so instead of facing up, it faces down. That's called a vertical flip. You with me? What do you think happens if I have this. What I say about everything inside the parentheses? It's horizontal. So this would be a horizontal flip. What's the problem with this? What happens when I flip this side to the other side? It's already there. What happens when I flip this side to the other side? So when you have this, it really won't change that graph, but that's not true for all of them. Like, what if I had this? Well, we haven't studied this particularly yet, but this is what the original looks like. What would happen if I had this negative into it is this piece right here would flip over to the other side. So it would look like that. And this piece would flip over the X or the Y-axis and turn out to look like this. Does everybody see what it means to be a horizontal flip? It means this piece comes over here, this piece goes over there. I always think of these guys as pretending like, you ever sign a yearbook and the ink is still wet and you closed it too soon? And then you open it up and you have a mirrored image on the other page of that? It's like, pretend like I'm folding the y-axis and the ink is still wet here. The ink is still wet here. And I fold across this line. This is going to show up here. And this part right here is going to show up over there. Does that make sense? That's how I always help myself remember the reflections. Same thing if I did a vertical. If I did a vertical and this is what I drew, and I fold across here, I fold it down, the ink's still wet, that's going to appear. That's a reflection. Okay? Questions on that? Good so far? All right, tell me what happens here then. Actually, oh, we'll do that one, whatever. What does this tell you? Right 2, what does this tell you? Up 4, what is, oh, this is supposed to be a 2. What does that tell you? This tells you parabola, this tells you right 2, this tells you up 4, what does this tell you? Flip, so normally my parabola is facing this way, so I know when I graph this one, it's going to be facing down. And I know it's going to be to the right 2 and up 4. So it's going to look like this. This is where I normally am, right? And I'm normally facing up. This one is actually going to be to the right 2, up 4, and then facing down. That's an idea of what this thing should look like before I even graph it. Because I know what all that crap does to it. Does that make sense, yes or no? Why'd you say V shape? So I know it's going to be a V shape. What else do I know about this thing? Left 2. What does a stretch by 5 mean? It's going to get really skinny. So normally my normal V is like this. This is going to be, I mean, like really skinny, like almost like that, like straight up and down, because That's a big 5. That's going to stretch it really high. And up 3. So that means I'm going to be left 2, up 3, and I'm probably going to be at a shape like this. Because what happens is every output gets multiplied by 5. Right? So I got to do order of operations. So normally, if I just did the original one, right? If I put a 0 in, I get a 0 out, right? But if I put a 1 in, I just get a 1 out. Watch what happens when I put a 1 in here. 1 plus 2 is, but then I go 3 times 5 is 15. My output's now at 18. Because that 5 multiplied it. So now that means I'm just going over 1, but I'm now going up way more than I was over here. Over here, it's just kind of going up 1 over 1, up 1 over 1. Now I'm up over 1, up 18. So it's going to be a really skinny. Kind of making sense? All right, what if I told you this? F of x, and I tell you the x and y's. By the way, I'm totally making these up. And I told you g of x is equal to f at x minus 2 plus 4. Give me the x and y. No, because I don't know what f of x is. I don't know what shape, and I totally made this up, so it's not really an equation right now. It's not got an equation that makes this. I made these numbers up. That's not the point, though. It'll be okay right now. Why do you have 1 for x? Is that what I'm supposed to do? What is this going to do to every one of my ordered pairs? It's going to move it right to. What does that mean I'm going to do to all my x values over here, guys? Add 2. So instead of being 3, it's going to be what? 5. Instead of being 7, it's going to be. And instead of -4, it's going to be. Do you guys see how I do that? I did that. Because I knew this moves it right to, it only affects the x coordinates. Kind of. What would this do? Add 4, and that would mean it's up 4, right? That means up 4. So that means instead of, I'd add 4 to all my y's. So instead of 2, it's going to be a. Instead of 9, it's, and 8, it's going to be. Kind of follow me on that. Yes or no? I'm kind of getting ahead with you guys, but that's okay. I was able to move faster with you. If I said f of x equals 5x squared. I did? Yep. He's already on it. Exactly, that's perfect. What did I say? Anytime you are inside the parentheses, what did I say it's going to be? And it's always the opposite of what you think. So here's what I mean by that. Remember when it was bigger than 1, I called it a what? A stretch, right? So what do you think, since it's going to be the opposite inside, what is that going to be now? Now, be careful on this. Pretend, what does a compression mean? Compression means pushing together, yes? So what would happen if I horizontally compress this? It's going to make it skinnier. Careful, listen. When I am here and I'm vertically, that means I'm pulling This, I'm taking this right here, and I'm pulling it up. That's vertical. That made it skinny. But when I do a compression horizontally, I'm pushing it from the side. See, the other one was vertical, so I was pulling vertical. When I compress from horizontally, I'm pushing it. What does a horizontal compression look like? A horizontal compression gets the same result as a vertical stretch. It makes it skinny. Because it's like me pushing it from the sides, it's going to compress it like that and make it skinnier. What does a horizontal stretch, or if I pulled the sides, it makes it wider. What does it look like? A vertical compression. So like when I do f of x equals 1/2 x squared, I would call this a horizontal stretch. And why? Because they would be taking this and they'd be stretching this out, which would make it wider. So a great question that they kind of ask is, what is similar to a vertical stretch? Your answer would be a horizontal compression. You get how they're similar? Yes? All right, you guys have the last couple minutes. Sweet. You will have homework tonight. You will have homework tonight. What'd you ask?
I said, is that you? I thought you were playing like Kodak or something.
No, that's
Did you say there is homework tonight?
There will be homework
Hey,
tonight.
Bella, have a great day.
Is the homework on what?